Hi, in this video I am going to explain about reaction in organic chemistry. There are thousands of, maybe tens of thousands of type of organic reactions, but I'm going to explain the simple one only, the one that being tested in O-level or IGCSE. And I already make a diagram for the organic reactions, the one that they commonly ask. Let's see this diagram here. If you notice, I draw the boxes there. The boxes indicates the functional group or homologous series, right? I have how many here? 7 boxes. The first one is alkane, alcohol, then carboxylic acid. Below we have 3 more boxes, alkyl halides. Alkyl halides is organic substance that contain halogen, like fluorine, bromine, and iodine, yeah, and addition polymer. Below here we have ester, which is made from alcohol and carboxylic acid. This I'm going to explain all the reactions. The arrow there in this diagram indicates the reaction from one functional group to another functional group, right? So I'm going to explain the first 6, or the first part of this video. I'm going to explain 6 only. 1 is from alkane to alkene. 2 is the opposite direction, alkene to alkane. 3 is from alkene to alcohol. 4 is the opposite of that, alcohol to alkene. 5 is from alcohol to carboxylic acid, and 6 is from carboxylic acid to alcohol. The name of the reaction, number 1 is cracking, where you break up the substances. We are going to go through detail later on, right? Number 1 is cracking from alkane to alkene. Second one is called hydrogenation. Okay, we go through one by one. The first one is cracking. Cracking is from alkane, and the alkane must be a long chain that you're going to break up into several parts, right? So you have a long alkane. So imagine you have a long alkane like this, then you break it up, and in the process you're going to produce minimum 1 alkene, right? The catalyst also you must memorize. The catalyst is Al2O3 and SiO2, 450 degrees Celsius and 200 atm. Besides this, we have some other catalysts, but the one that we are learning now, the simplest one, is only Al2O3 and SiO2. Or this is simply just, what is it? Sand, right? SiO2 is sand. So it's high temperature and high pressure, right? And the example of cracking reaction, see example 1, cracking of hexane. Hexane is 6 carbon. There are many ways you can break it up, and it's random. You can break up to produce hydrogen, and the remaining one you're going to produce C6H12, which is called hexene, right? Or another possibility is you can produce methane, CH4, which means the remaining chain will turn into C5H10, which is pentene. Yes? Or you can produce C2H6, which is ethane, and the other chain will be butene. produce propane, and the alkene you produce is propene. Or you can produce butane, then the alkene that you produce is ethene. So this is random process, unless the question mentioned that you produce some product, you're free to break it, to break the 6 carbon in any way you like. So that's reaction number 1. I'm giving you another example, cracking of octane, right? Octane is C8H18, then it can produce also different type of product. Depends on how it cuts, right? Next one, if you remember, the reaction number 2 is you're producing alkane from alkene. Quite simple. The name of the reaction is hydrogenation. Simply means you're adding hydrogen. The catalyst is nickel, temperature is 200 degrees Celsius. The reaction pattern, alkene plus H2, you produce alkane. That's it. The example here, yeah, C2H4. This is called ethene plus H2, you produce ethane. How it works? Very simple. There's a double bond between the 2 C. You cut that bond and you put 2 hydrogen into that one. So that way you can increase the number of hydrogen in the organic compound by 2. That's why you get alkene. And the product is called, of course, called ethane. Yeah. So that's reaction number 2. Another example, you can do hydrogenation of a longer chain. For example, hydrogenation of propene. Same catalyst, 200 degrees Celsius, nickel catalyst. When you do hydrogenation of propene, what will you get? Propane, of course, right? Then you're adding 2 hydrogen to the propene. That's why you get propane. Then another example is hydrogenation of butene, which of course produce butane. That is reaction number 2. Next one is reaction number 3 is hydrogenation. No, hydration. Yeah. Reaction number 3 is called hydration. From alkene you produce alcohol simply by adding water, but of course not in the liquid form, but you get it from you get it in you use steam, yeah, H2O gas, which is steam or water vapor. The catalyst is H3PO4, also called phosphoric acid. Temperature is 300 degrees Celsius. Pressure is 60 atm. You must memorize that catalyst, it will come out in O level. The reaction pattern, very simple. Alkene, yeah. Alkene, you add water. Then the double bond, one of the bond in the double bond break up to, and you can put in OH there, right? Example 1, hydration of propene. If you have propene like this, plus H2O, then you get the OH will go to one of this carbon. So you're going to get something, propanol. Yeah. So if you do hydration of alkene, what will you get? you get alcohol. Yeah, and this is the molecular formula. C3H8 is propene, C3H7OH is of course propanol. The opposite of that reaction, where you can produce alkene from alcohol, that reaction is called dehydration. Right? Dehydration means you are taking away water from the organic substance. And you have alcohol. The alcohol, you convert it into alkene, and the byproduct is H2O. And how do you do that? By using a catalyst or drying agent. And the drying agent here is H2SO4, also called sulfuric acid. Concentrated sulfuric acid. Yeah, and the temperature is 170 degrees. The reaction pattern very simple. You are removing OH and the neighboring H in the organic substance to produce H2O, and the bond that is used to connect to the OH and H is forming a double bond between the two C. That is the pattern. The example, very simple example, dehydration of propanol. Dehydration of propanol to produce propene. You have propanol with one OH here, and you remove the neighboring H, and you form H2O there. The organic product is a double bond like this. It's called propene, C3H6. Yeah? So you're removing H2O from the molecule. Reaction 5. Reaction type 5 is called oxidation. Oxidation simply means you are adding oxygen to the organic substance, and you need to do that you need the oxidizing agent. And in the chemical equation for organic, the oxidizing agent, we use a certain symbol called the square bracket O. Yeah? Square bracket O is the symbol of oxidizing agent. There are a lot of oxidizing agent you can use to oxidize organic substance, but for O level, the one that you must memorize, you need to memorize two only, the common one, the one that is commonly used. The first one is KMnO4, also called potassium permanganate. Some books call it potassium manganate 7. It means the same thing. The color of this substance is purple, and when it reacts to oxidize something else, the color will change to colorless. So when you put KMnO4 into a solution and the color of KMnO4 change from purple to colorless, it means that the KMnO4 is oxidizing something, yeah? Which means there's a reducing agent in the substance, right? Another common oxidizing agent that people use is the potassium dichromate, K2Cr2O7. The color will change from orange to green. So potassium dichromate itself is orange, it will turn to green after it reacts. Okay, and remember the symbol is a square bracket with O inside. Right, the reaction pattern. Here, the reaction pattern is like this: alcohol plus oxidizing agent. You're going to produce carboxylic acid and water. Yeah. If you see here, C with OH will turn into COH, which is a carboxylic acid, and the box there, the black box there, is used to indicate other part of the organic substance that is not affected by the reaction. Okay, then the example for this oxidation of ethanol. Yeah, so you have ethanol or C2H5OH. You add oxidizing agent, then you're going to get ethanoic acid or CH3COOH. The byproduct is of course H2O. This square bracket O again is just a symbol. In the practical, either you use potassium permanganate or potassium dichromate. Example 2 is oxidation of propanol. Very similar. Propanol C3H7OH, you oxidize to C2H5COH, which is propanoic acid, and you're using oxidizing agent, then the byproduct is of course water. Yeah. So that is reaction number 5. If we look at the diagram, yeah, we have learned quite a lot. Okay, we do number 6 now. I'm going to explain number 6. After that, we revise the catalyst one by one again. Okay, number 6. No, not this one. Number 6 is called reduction. Reduction, which is the opposite of oxidation. And to do that, you need a reducing agent, and the symbol of reducing agent is H with square bracket inside. Yeah? There's the symbol of reducing agent. Again, there are a lot of reducing agent for organic chemistry reaction, but we must memorize only 2. The 2 common one. One is lithium aluminium hydride, LiAlH4. So remember when you learned about redox last time, if they mention hydride, means the H is negative 1. Yeah? The charge of H is -1. Oxidation state is -1, which make it a good reducing agent. The second reducing agent that you must memorize is sodium boron hydride, NaBH4. You add that to carboxylic acid, then you have this reaction pattern. Carboxylic acid plus the reducing agent, then you get alcohol and water. This is the pattern. Something COH, the box here means the part of organic substance that is not affected. Then become alcohol. The example 1 is reduction of ethanoic acid. Ethanoic acid is CH3COH. If you reduce, the COH will turn into COH with the 2 hydrogen, of course, right? You must add the reducing agent to do that, and the byproduct is of course H2O. Ethanoic acid will turn into ethanol. So that's example 1. I can give more example. Propanoic acid, you have COH, which make it carboxylic acid, and the box here is C2H5, which is part of the organic substance that is not being affected by the reaction. Then the COH will turn into COH, which is why the propanoic acid turned into propanol. The byproduct is water. So that's the first part of our reaction, where all the simple reaction only for polymer, right? The simple one. We quickly revise. Hopefully you still remember the catalyst, condition, and so on. Okay, what is reaction number 1 here? Yes, it's called cracking. The catalyst is something Al2O3 and SiO2 for 150 degrees Celsius to 100 ppm. Reaction number 2, hydrogenation, nickel to 100 degrees Celsius. And no, I'm not cheating. I didn't read any notes. This is because I've been teaching for so long, so I remember, right? Number 3 is hydration, right? Catalyst is H3PO4, also called phosphoric acid, 60 atm, 300 degrees Celsius. Yeah. Reaction 4 is dehydration, is concentrated H2SO4 and 170 degrees Celsius. Yeah. Reaction number 5 is oxidation, from alcohol to carboxylic acid. It's not called catalyst, it's called oxidizing agent. And the oxidizing agent, you have 2, potassium permanganate, and the color will change from purple to colorless, or potassium dichromate, the color will change from orange to green. That's reaction from reaction 1 to reaction 6. Next part, we are going to do the rest of the reaction number 7, 8, 9, 10, 11. Okay, we do one by one now. We go to reaction number 7. Okay, where is it? I think it's here. Yeah. Reaction number 7 is a little bit more complicated because you have 2 reactants, and the 2 reactants are both are organic substance. Then they react together and combine to form a new substance. Reaction number 7 is called esterification or condensation. Reaction pattern, very simple. Carboxylic acid reacts with alcohol to produce ester, and the byproduct of this reaction is water. Catalyst is concentrated H2SO4, and this is the reaction pattern. Carboxylic acid, something with COH, and alcohol, something with OH. They react together to form ester. That means the carboxylic acid and the alcohol, they join together, and in the process they are removing the OH and H to form water. Yeah. The OH you take it from carboxylic acid, H you take it from alcohol. Then you form ester. Yes. Hopefully you can understand. It's quite confusing for some students, but we just try to do this online. We use example 1. Propanoic acid plus methanol. Propanoic acid, C2H5COH. Yeah. Methanol is CH3OH. Yeah. And the OH here will react with the H there to form H2O. And the byproduct is the main product, the organic product is methyl propanoate. If you look at this thing, my explanation with the color there maybe is a bit easier. Propanoic acid, 3 carbon here, and you have 3 carbon on one side. Methanol have 1 carbon, and you have 1 carbon. So you join them, then you have the ester functional group. Yeah? Yeah, like that. The name also, since it's methanol, then the name of the ester contains ethyl. Since you use propanoic acid, then the name of the ester is something propanoic. Yeah? So that's the first example. We try this example too here. Oh, no, this is the same one. Okay. Yeah, we do reaction number 8. See number 7 here. Number 7 here is alcohol and carboxylic acid combined to produce ester. That's reaction number 7. Reaction number 8 is the opposite of that. Ester break up to produce carboxylic acid and alcohol. The name of the reaction is hydrolysis. Okay, hydrolysis, very simple. The opposite, this is the pattern. Ester plus water will produce carboxylic acid and alcohol. The catalyst is dilute HCl. See, we have ester plus water, then it will break up. Yeah? One part will turn into carboxylic acid, the other part will turn into alcohol. Yeah? You need water because you need water to break up. Yeah? The water is used to break up the ester functional group here. Yeah, we use example 1. Hydrolysis of ethyl butanoate. Ethyl butanoate is this one. Yeah? This part we call it ethyl. Yeah? Because it contains 2 carbon. Butanoate is this one. See, 4 carbon. So ethyl butanoate. The butanoate will turn into butanoic acid. The ethyl portion of the ester will turn into ethanol. Yes? So hydrolysis of ethyl butanoate will produce butanoic acid and ethanol. You need water, of course. Then the catalyst is hydrochloric acid, dilute. Yes. Then the next one, reaction number 9. Reaction number 9 is to produce alkyl halides, or some book call it halogenoalkane. Yeah? This is called halogenoalkane. And what is that? It's an organic substance that contains halogen. Right? All these halogen have only one bond, so it displaces the hydrogen. The hydrogen, either you displace it with either F or Cl or Br or I. So that's reaction number 9. I give a simple explanation for that. Yeah? Okay, the name of the reaction is substitution. In JC, you're going to call it free radical substitution. The catalyst is UV light, Even the normal light contain UV light, yeah? But if you put UV, then it will be faster. The reaction pattern, alkane plus halogen. This X2 is the symbol of halogen, yeah? Symbol of halogen. The X2 can be several possibilities, F2, Cl2, or Br2, or I2. It can be 82, but 82 is not in syllabus. It's radioactive, right? So we seldom discuss that one. Example 1, chlorination of ethane. That means ethane you add chlorine. Yeah? That's how you do it. Chlorine, yeah? You add ethane. This is easier. One of the chlorine goes into the ethane, make it chloroethane. And to do that, you must displace the hydrogen, and the hydrogen reacts with the other chlorine. So the byproduct is HCl. One more thing. HCl, if you do organic reaction and you produce HCl, the observation that you will see white fumes. The white fumes are dangerous. Don't inhale, right? You better off using protective goggles because HCl is very, very acidic, right? So be careful when you do this reaction. So one of the Cl or one of the halogen goes into the organic substance. The other Cl will stay outside and it will receive hydrogen from the organic substance. Then you produce HCl or HBr or HI. Yeah. That is reaction number 9. Next, reaction number 10. Reaction number 10. Reaction number 10 is called bromination. That means alkene. You are going to add bromine, then you get alkyl halides. In this case, the alkyl halides is bromine, right? The explanation is this one. This one, yeah, bromine. The name of the reaction is bromination, or you can also call it addition of bromine, or you can call it test of alkene. Then the reaction, very simple, alkene plus bromine, you get dibromoalkane. People use this reaction to test whether you have alkene in the solution. How to do that? You add aqueous bromine, which is easy to keep because it's aqueous. Then you just pour a little bit. The bromine itself is brown. If the reaction contains alkene, the brown will quickly decolorize, will turn colorless. If the solution do not contain any alkene at all, or don't contain any double bond, it will stay brown. So it's easy for you to test, right? The name of the reaction is addition of bromine. This is the example. Yeah. Bromination of propene. Propene have a double bond. I marked that with blue color. One of the bond and a double bond. You add bromine, and the bromine will open up this double bond, and the two bromine will stay with the propene, which turn it into 1,2 dibromopropane. So this is the reaction. If you go through the detail, since the double bond is between neighboring carbon, if you draw the bromine on separate carbon, the one that is not connected, then it will be a wrong answer, right? So this one, 1,3 dibromopropane is not a product of this reaction. Yeah. So this is the example. Yeah. Propane is colorless. This is colorless. This is brown. And the product, dibromopropane, is colorless. Okay. This is another example, ethene with 2 carbon. If you react that with bromine, then you get 1,2 dibromoethane. That is reaction number 10 for bromination. Now the last reaction is reaction number 11, addition polymer. This is where you produce a polymer. Most of them are plastic, right? So you have addition. The name of the reaction is addition polymerization. Okay, I explain that. Now, this one. Addition polymerization. Let's say you have an alkene with a double bond, and one of the bond I mark that with brown color, and you can add catalyst. The catalyst itself is not in syllabus. It's not in JC syllabus also. Then if you add catalyst, then this bond, the one that I mark with brown, will break up to form bond with the neighboring molecule. Right? Some students have difficulty understanding this, but I can give an analogy like this. For example, there are 2,000 students in your school. Then these 2,000 students, you group them 2 by 2, right? The students are this carbon here, and you join your hand. You hold hands with the other student, so that both of your hands are connected, and one of the hands you mark with brown color here. Let's say this is you. This is one of your hand. The other one of your hand you mark with brown color, and your leg is connected with something called R2 and R1. Your friend's leg is connected with something R3 and R4. Then, when catalyst is added, what all these 2,000 students, which is 1,000 group, do, they still hold hands with one hand, and the other hand is connected to another group of the 2 students. So that 2,000 students will form a very long chain, and that's called the polymer. So when you still group 2 by 2, that group is called monomer. After all of you join together, then you are called the polymer, right? So that's the simple explanation of this polymerization reaction. This is example 1. In this case, the right leg, your right leg and left leg are connected to hydrogen. That means R1 and R2 are hydrogen. R3 and R4 also hydrogen. Then when you form a polymer, everything is same except for the bond here. Yeah, you form a very long chain. The name of the polymer, very simple. You just add the word poly in front of the name of the monomer, and you're not allowed to change anything. You just add the word poly, right? So if the monomer is ethene, the name of the polymer is polyethene. Yeah. So that's the first example. Ethene, polyethene is a type of plastic, the soft plastic. It's called something cling wrap, the one that is used to cover vegetables in the supermarket. So that's polyethene. Example 2 is chloroethene. Chloroethene is very similar to ethene, just that one of the hydrogen you replace with chlorine. Then you have the rest are hydrogen. So the same thing here. This bond break up to form this bond and that bond. Yeah. You get the polychloroethene, and polychloroethene is another type of plastic, a harder one, right? A harder one, like your ruler. If you have a plastic ruler, is polychloroethene, right? Okay. Another example is propene. Propene is have 3 carbon, so 2 carbon like this, and one of the R. This is R1 is H. R2 also H. R3 is CH3. R4 is also H. So you have 3 carbon, and from the double bond here, break up. So you call it polypropene. And polypropene is another type of plastic, slightly harder than the polyethylene. This is example 4. This is called tetrafluoroethene. You have R1, R2, R3, and R4. All of them are fluorine. That's why it's called tetrafluoro. Tetra means 4, means the ethene have 4 fluorine. Then you produce polytetrafluoroethene. What is polytetrafluoroethene? It's also called PTFE. In the market, it's called Teflon. And what is Teflon? Teflon is the black substance, the one that is used to on the frying pan, right? To make it a non-stick frying pan. So that's it. We have covered all the 11 reactions for organic chemistry. It's not a complete one, but for O level is good enough for O level, right? So this is the diagram again. We memorize, we revise very quickly. We have 11 reactions. Reaction number 1 here. Remember what is the name? Cracking. Catalyst is Al2O3 and SiO2. Reaction number 2 is hydrogenation. Catalyst is nickel. Temperature 150 degrees Celsius. Reaction number 3 is you're adding water, so you call it hydration. H3PO4, phosphoric acid, 300 degrees Celsius and 60 atm. Number 4 is dehydration. The drying agent is concentrated H2SO4, 170 degrees Celsius. Number 5, from alcohol to carboxylic acid, is not called a catalyst, it's an oxidizing agent, and you have 2 oxidizing agents, KMNO4 or K2Cl2O7. If you use K-4, color will change from purple to colorless. If you use K2Cl2O7, the color will change from orange to green. Number 6 is the opposite of number 5. It's called reduction. Yeah. Remember, you need the reducing agent, and the reducing agent are LiAlH4, lithium aluminum hydride, or NaBH4, sodium boron hydride. Reaction number 7 is called esterification or condensation. Alcohol you combine with carboxylic acid to produce ester. Catalyst is concentrated H2SO4. Reaction number 8 is the opposite of that, which is called hydrolysis. Yeah, dilute HCl. Ester break up into alcohol and carboxylic acid. Reaction number 9 is free radical substitution or just substitution. Catalyst is UV light. The product is alkyl halides, and the byproduct is HX. HX can be HCl, HBr, HI, and you will see white fumes as you will observe white fumes. Number 10 is bromination or addition of bromine. The color change from brown to colorless. Reaction number 11 is addition polymerization to produce polymer from alkene. Yeah. So that's all the 11 reactions that we cover in this video. Thanks for watching. Alright, and please memorize all this reaction for your O-level test. Okay, see you.